Hello everyone. Thank you for being here today. Myself, Navdha Soni, Assistant Professor from Quality Assurance Department at LJ Institute of Pharmacy. I'm here today to talk to you about antifungal agents. So let's start antifungal agents. First of all, we will start with introduction. What is fungi? Fungi are eukaryotic cells. They possess mitochondria, nuclei, and cell membrane. They have rigid cell wall containing chitin as well as polysaccharides, and the cell membrane composed of that ergosterols. While bacterial cells are prokaryotic, so antibacterial agent can exhibit selective toxicity. In contrast or in reverse, similarly, between fungal and mammalian cell make antifungal drug non-selective. So, antifungal drugs are in general more toxic than the antibacterial agents. Depending upon the basic difference, they may be classified as phycomycetes, which is having structure like algae, ascomycetes, structure like sec, basidiomycetes, structure like mushroom, and deuteriomycetes. This is the overview of fungal infection. You can see here the pictures of fungal infection of tongue, nails, and other skin part, on other skin part. Fungi that can cause infection like association with human commonly and in environment. Fungi infections generally termed as mycosis. So in the UK, the common fungal infection is systemic candidiasis. These are the pictures of candidiasis infection. Clinical classification of mycosis. Mainly four types of mycosis: cutaneous mycosis, subcutaneous mycosis, systemic mycosis due to opportunistic pathogens, and systemic uh, mycosis due to the primary pathogens. We know about cutaneous and subcutaneous mycosis. What is systemic mycosis due to the opportunistic pathogens? They are due to the opportunistic pathogens are infection of patient with immune deficiency who would otherwise not be infected. In the contrast, systemic mycosis due to the primary pathogens, they originate primarily in the lungs and may spread to other organs. If we want to develop any antifungal agent or any antifungal drug, we have to know about targets. What will be our target for killing fungal cells? So these are the four targets. First, antifungal therapy generally depends upon biochemical difference between fungi cell and mammalian cell. What will be the difference of fungi cell and mammalian cell? So we can attack on particularly fungi cell. On cellular level, they have cell wall, whereas mammal cell doesn't have cell wall. We know that. So fungal cell is a target for those chemicals which inhibit the cell wall synthesis, because mammalian cell doesn't have cell wall. Okay. Cell membrane of fungal cell contain different sterols, as we know, ergosterol. Okay. Different sterols which are essential for structure of cell membrane. And other targets include inhibition of DNA synthesis, disruption of mycotic spindles, and interference in the metabolism. Most important part is classification of antifungal agents. These are the major classes of antifungal agents: pollens, or mostly antibiotics. Azoles. Azoles further classified into trazole and imidazole. Fluorinated pyrimidines, natural products, chitin synthetase inhibitors, peptides or proteins, and miscellaneous agents. We will see one by one. First of all, polines. These are the examples of polines: natamycin, nystatin, and amphotericin B. What is the mechanism of action of this polines, or specifically amphotericin B? I know that the structure of polines are very difficult to understand or difficult to remember, but we have to remember. Okay. In the diagram, you can see this amphotericin B is directly bind to the ergosterol, which is the part of cell membrane. Okay. So when ergosterol will bind with this amphotericin B will directly bind to ergosterol, it creates channel or it creates pore inside the cell wall. So by formation of this channel, the essential electrolytes and small molecules of cell will leak out. So ultimately resulting into the cell death. These drugs are especially effective against fungal infections like Aspergillus and Mycoses and Candida infection. Second class is azoles. In first, there is a triazole. Triazole having two examples, fluconazole and itraconazole. These are the two most important drugs, that is fluconazole and itraconazole. What is the mechanism of action of this fluconazole? You can see here, lanosterol is converted into ergosterol, and as we know, ergosterol is essential part of cell membrane. So when lanosterol is converted into the ergosterol, this fluconazole will interrupt the conversion of lanosterol to ergosterol. So ultimately, the synthesis of ergosterol will be inhibited by this flucytosine. So ultimately, ergosterol will not be synthesized and the cell wall synthesis is inhibited. They are active against same like Aspergillus, blastomycosis, and Candida species. Next, very important, that is imidazole. Imidazole derivatives. There is lots of examples of imidazole derivatives are clotrimazole, iconazole, ketoconazole, tioconazole, terconazole, miconazole, butoconazole, and oxyconazole. These are the examples of imidazole. Recently, if any fungal infection is diagnosed, so first line drug, that is imidazole derivative. Generally, they prescribe ketoconazole or butoconazole. How it acts on fungal cells? Imidazole derivatives act by damaging the fungal cell membrane, same like triazole. Okay, they enhance the membrane permeability. By inhibiting the synthesis of ergosterol, same like earlier. Okay, so synthesis of ergosterol is inhibited, which is primary cellular component of fungi cell wall. They are effective against superficial as well as systemic infection. In the syllabus, they have mentioned the synthesis of miconazole. So these are the few steps for the synthesis of miconazole. Next is fluorinated pyrimidine. Example is flucytosine. Student, by seeing this flucytosine, remember the structure of pyrimidine is resembled like with flucytosine, or flucytosine is nearly similar to the pyrimidine derivative. Of course, it is pyrimidine, fluorinated pyrimidine. Okay, so we have to understand, if faulty pyrimidine gets incorporated into the DNA synthesis, so ultimately faulty DNA will be formed and target is achieved. If faulty DNA will be formed, so otherwise, the fungal cell which ultimately faulty DNA leads to the death of fungal cell. Okay, so they are active against, they sorry, they suspect to interference in protein synthesis also. This fluorinated pyrimid of flucytosine also inhibits the protein synthesis process. So it is very effective against various fungal infections. Major use of this drug is mammalian cells do not contain cytosine deaminase, so their function is not affected by flucytosine. They only target on fungal cell, not on mammalian cells. So it is the advantage of usage of flucytosine. Natural product example is griseofulvin. It is only fungistatic and it causes number of significant drug interactions. How it acts? Griseofulvin accumulates in newly synthesized keratin containing tissues, where it causes disruption of mitotic spindle and inhibition of fungal mitosis. It inhibits mitosis process, so there is no spread of fungal cells. Next is chitin synthetase inhibitor. Example is nicomycin. It is found to be potent growth inhibitor of Candida albicans through competitive inhibition of chitin synthetase. Name itself suggests it is chitin synthetase inhibitor. It means the synthesis of chitin by the enzyme chitin synthetase is inhibited by this nicomycin drug. Next is peptide or protein. Example is cispentasine. Cispentasine do not inhibit amino acid biosynthesis. It is not inhibited by amino acid biosynthesis is not inhibited by this protein or peptide or cispentasine in vivo, but it elevates the level of several amino acids, possibly by interfering with self-regulatory mechanism. It is active against Candida albicans. It does not inhibit the synthesis of amino acid, but it elevates the level of several amino acids. Miscellaneous agent: benzoic acid, salicylic acid, nitroxaline, naphthene, and tolnaftate. In the syllabus, they have also mentioned the synthesis of tolnaftate. So it is very simple synthesis of tolnaftate. Thank you so much, everyone, for watching me. Thank you. Thank you once again.